All right, hello once again, Jeff Scott of Rankin Technical College. And this morning for the AWD1100 C# programming class, the online class for the summer 2023 semester, unfortunately, my internet must have cut out 3/4 of the way through. So you've got 3 hours of a 4-hour lecture, and I went another 15 minutes, and that isn't in there. So I'm going to re-go over, I guess, Chapter 7 right now. The chapter is on exception handling. What I did at the beginning of class, and you will get this, but at the beginning of class, I went over this right here. Why it's got Tree Master, I don't know. But I did 5 examples of a fairly simplistic miles per gallon program. All right, and the first 3 examples are all console apps. The first console app, everything is in main, and it's real simple, and there is no error checking. Then I went back and redid it with error checking using if statements. Then I went back and redid it using exception handling with try-catch statements. All right. Then I did something similar with this with a GUI project. I did it first with if statements, etc., and then redid it with exception handling. That'll be out there. It's out there right now. In addition, I went through and in chapter 7, they go through 2 iterations of a future value program. I went through both of those as well. All right, so let's just talk about what we've done. So the chapter is broken up, as always, into several sections: an intro to exceptions, how to use structured exception handling, how to validate data, then the future value app with data validation. It's in here twice, once with data validation and once with straight exception handling. We'll look at both in just a bit. Now, when you talk about exception handling, they're exceptions to the rule. An exception in a program is not a good thing. It's an exception to the norm. Typically, it means something went wrong. All right? All programs get this now and then. If you don't handle exceptions when they come up in a program, the program or the software itself will handle the exceptions. And typically what it will do is it'll shut the program down. That's typically what it'll do if it gets an exception. Now, the act of you being able to handle exceptions is known as exception handling. And what you'll see in a couple minutes is you typically use what's called a try-catch mechanism to do this. All exceptions are part of the exception class. When we look at this picture here, I went through examples of this morning earlier in the earlier tape, where we purposely introduced some errors in there so you could see them. Here's a format exception error. I showed that this morning. I showed a divide by zero exception. I showed an index out of range exception. So there are several examples of those. Now, this is not a complete list here. There probably are upwards of 100 different exceptions in C#. All of them are based off of the exception class, all right? And they go from most general to most specific. And when you put them in your code, you must put the most specific ones before the most general ones. In other words, if you put exception handlers in your code in this order, everything would be caught by exception. It would never find the format, arithmetic, overflow, or divide by zero exceptions. So if I was to put these 5 exceptions in my program, I would first put these 2, and the order probably won't matter. So maybe I do an overflow exception, then a divide by zero exception, then probably an arithmetic exception, then a format exception, and then an exception. Methods that can throw exceptions are convert and decimal, date time, and there are other ones as well. So typically when you do this, this is a very kind of a silly example, but what they're showing here is how to use the message box with a message box.show. And they say in chapter 10, you'll learn more. I showed you this from day one, so there's not really any sense in going over that part. All right, so to catch exceptions, this is the format here. So in this try statement, or I should say not a try statement, in this try block, and it's a block because it's between curly braces. So in this try block, all right, in this try block, you put in one or more statements that could conceivably fail. Then, depending on how they may fail, you put one or more catch statements in there. Again, this is a kind of a silly example. They don't have the kind of error that you'd get. It'd probably be like a format exception, but they just did it like this. I don't know why. I know that, and I'm a proponent of the crawl, walk, run mentality, but I also want them to show you examples in a way that you're probably going to use them. You're probably never going to do anything just like this. Now, exceptions come with some stuff built in. The thing that is most important for the exception is the message. And it's a brief little summary of what went wrong. All right? So, for instance, if you look in here, they're saying use a convert to decimal, okay, for the subtotal. And if you left it blank or you put something non-numeric in there, it would come up with something like this. The input string was not in a correct format. All right? You can also include in there a get type, which shows you the type of exception. I don't know if I've ever used that. A stack trace is kind of interesting that they mentioned there. Imagine you have a program, and I'm going to make this real simple. Try to at least make it real simple. So in my program, I've got this. I've got function 1, and there's some code in there. I don't care what the code is. All right, so there's some code in there. But let's assume that it calls function 2. All right, and then we've got function 2. And it's got some code in there. And let's assume that amongst other things, it calls function 3. And amongst other things, it calls function 4. And let's assume that somewhere in your code, put a comment there in here, an exception is thrown. I don't know what it is. I don't know what caused it. I don't care. But if you run a stack trace, it'll show you that you were in function 4 when the exception was thrown. It'll show you the line in section 3, in function 3 that called function 4. It'll show you the line in function 2 that called function 3 and the line in function 1 that called function 2. When it's a back trace, so it's a last in, first out. It shows you the last functions that were called in a last to first type of order. All right. The author mentions it a little differently. Maybe his wordage is better. The stack trace is a list of the methods that were called before the exception occurred. It appears in a reverse order from the last method called to the first method called. Now, if you want to catch specific types of errors, you can have more than one catch statement. So if you notice in here, we've got a format exception, an overflow exception, and an exception. And again, what we're saying is this particular exception, the one that's called exception, is more general in nature than this one and this one. You have to put them in order in your code from most specific to least specific. All right? Now, They also have a finally block here. Okay? If you run this code, if these 3 lines that are here all work, if every line works and there's not a problem, you skip every catch statement. If one of these 3 statements causes a format exception, then it comes down here, it does these lines of code, and it skips the rest. If something over here causes an overflow exception, then it jumps down to here, it does the code, and it skips this. All right? If there's another kind of exception that's not a format exception and is not an overflow exception, it comes down and does this. So either it's going to do all 3 of these and skip all the catches and then do the finally, or it'll find an error in one or more of these lines, and whenever it finds an error, it jumps down to the exception. All right? The finally is used, as it says, for cleanup. It's housekeeping. When we get to chapter 17, we will talk about how to work with files, how to open files, etc. Well, a cleanup operation in a finally might be to close the file. Same kind of thing with databases that we'll cover in chapters 19 through 22. You can throw your own exception. If you look at the if statements that are in here, we are throwing our own exception. All right, why might you want to do that? Well, even though there are a lot of exceptions that exist, you might have code that you're writing that really doesn't have an exception that's associated with it. So you can throw your own exception. All right? So when you see the word throw like that, it means the programmer, him or herself, is causing the exception to happen. They give you some examples in here. It's basically when you're trying to do something and for whatever reason you can't do it, that is most often when you are going to throw an exception. Now, the future app program is in here now with exception handling, and I've already done this one. It's kind of funny. I basically keyed it in very quickly, but you won't be able to see any of that because, again, it didn't work. So let's look at the first one. This first example, I'm going to show you all 3. This first example of an exception try this again. Come on, close and close. All right. So this first example of the future value has no error or exception handling in it. So if I run this, and it's not going to run, I've got to change my startup project. So if I run this, and I leave anything blank, the program blows up. All right? There is no error handling in here. But if I do run it again and I put in valid values for everything, I get the right answer. All right? Well, that's not the one they show here. The one that they show here is the second example that I have in here. All right? It's V2. So we will make that our startup project. I will close this. I will bring this up. It's a different color. For all 3 of these, the interface is exactly the same. All I changed was the color. So in here, it's pretty much written the way it is in the book. I changed it a little bit. But we've got this. When you click the calculate button, it's got a routine it calls called get future value. Here it is. So what are we doing? We're doing the same thing in here that we did before. But now we're saying if this fails, go in and do this. If this fails, go in and do this. If this fails, go in and do this. So if I run this one, If I run this copy right here, remember before if I left it blank, it gave me an error. Now if I leave it blank, it gives me an entry error, and it lets me know what the problem is. All right, and then I can go back and fix it. So I can come in here. Then it does the same thing for this. So again, I can come back in here. Then it comes back and it does, again, the same thing. So if I say 10, there it is. But the advantage of this over what we did previously, all right, the advantage of this over what we did previously is the program now doesn't shut down. All right. So everything that we want to do is in this try block, except the call to actually doing the future value calculation, which is down here. All right. So everything is in the try block. If we get a format exception, it's going to show this. All right. So here we'll put in, let's change this to format entry error. Let's change this to overflow entry error, and let's change this to general entry error. All right, and then I'm going to do a file save all, and I'm going to run it. And I'm going to leave that blank, and notice it says now format entry error, so you can see which one is calling that. If I do it again and just put in something like this, now notice I get overflow entry error. All right. And I don't know if there is any other kind of error I can raise here, like a general one or whatever. We can try. So I think this is going to give me another format error right here. And it did. And again, oops, I can get an overflow error. All right, but I don't think I can get a regular general error. I'm trying to think of how I could make one of those happen, and nothing's coming to mind right now. Even if I put a negative number in here, I'm not told that it can't handle that. See what I mean? So it just gives me 0. So again, everything that I'm trying to do is within this try block. If something fails, depending on where it fails, I jump to the appropriate catch block and do that. I don't have a finally in here, but I could put in a finally. This is kind of a stupid thing to do, but just so you see it, I'll do a show message. And I'll just say in here, in the finally routine. All right. And the only reason that I'm putting that in is to show you that if I run this and I put valid values in, so I put in again 100, 7.5, and 10, notice after it prints this, I get that in the finally routine. If I run it again and leave this blank, it's after I do this, it still says in the finally routine. So what I was trying to show you is this runs right here. I'm going to comment it out. But that runs whether the try succeeded and no catches are executed, or whether the try fails and one of the catches is executed. Okay? All right. Now, from there, we go to data validation. Typically, you use data validation in conjunction with if statements, etc., and try catches. All right. Typically, when you'll have data in that needs to be checked, to make sure it's valid, such as numbers to make sure that they're numeric, ranges to see that something has been, is in a range, to see if something even exists. Well, what's shown in the textbook here, all right, what's shown in the textbook here on 219 are some generic methods in this book for handling the presence or absence of a value, whether a value holds a decimal or not, whether a value holds a range or not, or the value is within a range. As they mention on the bottom of the page, since it's common to need to check text boxes for valid data, it makes sense to create generic methods such as these. All right. When we get to chapter 12, they mention that we'll put them in a class or in a class library. Don't worry about that right now. All right. So validating multiple entries, what they're doing here is they're creating a field that's called error message. And then they keep concatenating to it, plus equal, plus equal, plus equal. So every time you find an error, it'll be added to this. All right. And then finally, they go back again and they update the future value application to include this. I did this just so you see it. Let me go back here again. And now let me close this and let me open up version 3 of this. So this will again be, let's see, that's V2. We want V3. Set as startup project. And here it is. It's in yellow. And what you'll notice is if you look at it, all right, like before, we've got a try with just one catch. But now we've got a routine called is valid data. All right, and I changed around a little bit from what they have in the book. I have written there is decimal, there is int 32, there is within range, and there, oh, where's the other one? There's another one that's actually called is present, but we don't use it in here. All right. Also in the book, they hard-coded numbers here and here and here and here and here and here. Whoops, here. I put them in as constants. To me, that made more sense. All right. But we've got this try, and we validate monthly investment. We validate yearly investment. We validate rather years. If all those work, then we figure out the months based on the year. We figure out the monthly interest rate, and we call a routine to calculate. It's in here someplace. The future value. And you'll notice when we run this, if I leave this blank, I get 2 error messages. It tells me that it must be a valid, it's actually giving me 3 error messages right here. It's running through and it says this must have a valid decimal, this must have a valid decimal, this must have a valid decimal. All right? And then I can go back and add these. Let's make all these so they hopefully at least will overflow. All right. Now it says, again, the same thing. Must be a valid decimal value. Well, let's do this. Let me get rid of these. All right, the monthly investment, I'm going to make it $5,000, which is too big. The yearly interest rate, I'm going to make 25%, which is too big. For the number of years, I'm going to make 100. These are all out of range. So when I click calculate, I get 3 error messages, and each one shows me the correct range to use on these. And again, if I do come back and put in 100, 7.5, and 10, I get the correct answer. That's what this chapter is all about. I did go back, or earlier I went in and, like I said, I wrote 5 programs that went through and did different kinds of work, data validation, try catch, etc. with miles per gallon programs, and then we've got this one. Now I'm sorry that this cut out and I had to redo it. Now this is only going to be about a half an hour long, so if I went through this quickly and something doesn't click with you, you will have to let me know. All right? Today is Thursday. Hopefully everybody now has finished the test and turned it in. I will be grading those this weekend. This Sunday, the 4th, by midnight, you have to have the homework and the written tests, no labs, just the homework and the written tests for chapters 4, 5, and 6 complete. What that means is the 3 written tests, and then from here, 4, 5, and 6. Now, we did a few of these as a class. You must still turn those in. If you are behind on any work, I want it in ASAP, as soon as possible. Also, I'm starting it this weekend. If it's Monday, and I'm going to probably grade these things Monday morning before class, and you haven't turned in something, you're going to get a 0. And if you turn it in late, you'll still get partial credit, but it'll only be partial credit. All right? So Monday of next week, Monday of next week, the 5th, on Monday, we will be going over the next chapter in here. Please try to read the chapters in the book, and if possible, read them before you watch these tapes. All right? On Monday, we're going to talk about arrays and collections. It's a longer chapter than the one we just covered. All right? And I'm going to write a couple of programs for you that are not in the book, just so we can do some practice using these things. If we don't finish this on Monday, we'll finish it on Tuesday. But on Tuesday, we will do some of the homework problems. I don't know which. I will look at them this weekend. But from chapters 7 and 8. Those will be due on the 11th, along with that project here. Maintain student scores. We'll talk about all of this stuff next week. Wednesday of next week, by 7:00 a.m., I will email you another pretest. It'll be a pretest on chapters 7 and 8. I will give you from 8 till about 9:30 to work on it. Then at 9:30, I will create it for you from scratch. On Thursday of next week, 1 week from today, on the 8th, you will take your next hands-on test on chapters 7 and 8. I will again make sure to email you this by no later than 7 a.m., and I will go over the test from about 8 till 8:15 a.m. As always, any questions, please email me as soon as possible, jpscott@rankin.edu. And there is no such thing as a dumb or stupid or foolish question. I've been asked most everything. All right, I won't laugh. All right, so with all that said, have a good weekend. I will talk to you Monday, June 5th. See you then.